Okay, let's go to machining tab now. Let's get our robot up with this tab. We've got our tool, we've got everything here, and then we go to the first operation. Okay, so the first thing we're gonna have a look at is, shall we say we're gonna cut this section? Should we start with that one?
Yep.
The first thing we're gonna do is, we're gonna have it at E2 equals 0, E2 being the actual, so I'm just gonna close my window. So E2 being the table and 0 being the actual angle of the table. So 0 means that the rotation of the table is at 0 and it's facing the robot. And because our assist geometry is conveniently placed there, we're going to use E2 equals 0. Okay, so first thing we're going to do is going to drive faces, job assignment and drive faces. Then here we're going to go and find our part. So what we need to do is use that folder, yellow folder, go up, and we're going to go into assist geometry. And then we're going to go ahead and select the two faces, the two surfaces. So this is the one. We're going to press add, and then we're going to close out of it. And then here we have two faces here. And
sorry, so you didn't do it with the drive faces then, did you? Or did I miss that?
Yes, I actually just pressed drive faces.
Okay, and then you go into selecting the assist geometry through the drive face.
That's right. Yeah.
Okay, right.
And then it'll come out as a folder with the two surfaces. So then we can see here, we're zooming in, that we can see that there is a line at the bottom cutting on the underside of the surface, but we actually want it at the top side of the surface, because if it's on the underside, we're cutting more than the actual surface. We're cutting below the surface, but we always want this line, this is called the streamline, to be above the surface. So how do we change that? We simply double click on our surfaces, and then we go ahead and go alternate front side. And by doing this, it actually flips the direction of our surfaces. We press OK, and then we can see, okay, now it's at the top of the surface there.
I have a quick question in between.
Mm-hmm.
What was alternate streamlines again? Because when I used alternate streamlines, it did the same thing, or is it something else than alternate face?
Okay. Yep. So alternate streamlines. This actually means that it flips the U and V direction. So here we see that it's coming down and across, but if we actually check this one, it's actually appearing here.
Okay.
Yep, horizontally. And this orientation is not what we want, because you can imagine the wire cutting alongside this line, right? Rather than actually following the profile of the surface.
Mm-hmm.
So that's why we should go ahead and uncheck this one. And you also see that by default, the curve distribution is on auto. And that's just it, finding the best solution, the best streamline for your surface. And it seems to work okay here. Like it seems like, when I say that, it seems like it's cutting everything and it's cutting the edge here. So I would say auto is fine. But in some cases, you might find that it's not picking up all of your surfaces, and you might need to change this to something like from center. Oh, it's not reading it. I wonder why. Okay, let me try it again. Yep, and then now you can see that it's actually taking it from the center of the surface. Sometimes you might be like, no, actually I want it from the start. And that takes it from the start of the surface there. I mean, for this kind of surface, there is a little bit of a twist. You can see that. So sometimes if you do it from the start, it might not necessarily read that twist. So normally I would say it's usually auto or center, but let's just keep it on auto for now. It's reading that, reading that from the very edges of your surface. Okay, so let's just go ahead and run that. So running it actually just says, okay, I've made some changes and I want to confirm it. And then it comes up with a red exclamation mark, which says there's errors that you need to fix. So we know that it's not finished yet. Let's just have a look at how the robot is acting. So this looks good. You see the two bars there. It's facing up towards the ceiling. I'm going to call these the two A's because there's an A and an A. The two A's must be facing the ceiling, and that's good. That's what we want. But if you find that sometimes the whole tool has been flipped and the two A's are facing the ground, what you need to do is going into strategy and either clicking this on or off. So if we have inverse tool axis on, we go ahead and run that, you can see that the whole tool has been flipped. So if this is by default what you get, then you need to go ahead and uncheck or check this inverse tool axis, and it should fix your problem. Okay.
Just with the assist geometry, is it like typically better just to try and square off those ends so the tool doesn't come in at an angle like that?
Right, yes. So the point, it's probably best if you had this, yeah, as a square. Finishing off that surface there.
Yeah.
For now, let's work with what we have. It doesn't seem to, cut into anything else. So, but it is a good idea to square that off. So then what we can do now is then go to the next tab. It's links and leads. And what you need to look at here is the engage and the retract. I will also talk to you a bit about the extend, but let's do this leads first. So what leads is basically telling how the robot should enter that surface. So we see that it's off at the moment, but let's just go ahead and turn that on by choosing one of these. So we remember that there are actually several ways that we can enter a surface. We can enter it by normal, which is meaning perpendicular to the surface, or we can enter it by tangent, which is on par with the surface in the same plane, or by line, which could be in a 45-degree angle or 120-degree angle if you have a very tight space, and by arc. So let's go ahead now, and I think we can do, let's just do here by tangent, so that when we are coming in and cutting the block, we can just come straight down. So I'm going to just do it by tangent. And then here there's an option for you, the length. How long do you want that cutting surface to be? That engage length. And I'm just going to say by default, I'm going to give it 100 millimeters. Enter. Now let's go ahead and run it. Yep, and you can see that, okay, it's doing something funny there. It looks like 100 isn't enough. And we can actually just try and have a look at that by going into Simulation tab and then going ahead and playing this. It's kind of doing a twist, and then it's kind of cutting into the surface and then trying to cut it like that. So you can see here, this red, it means there's a collision. So that's something we need to fix. But let's have a look at how the surface is acting. Looks good so far. It's not having any problems with collision, and then it's gonna come out and pull out in that way. Okay, and it looks like when you're going up, it's also cutting across that. All right.
Those sort of collisions there is like that last one. Is that something you just to sort of ignore and go, it's fine, because obviously it's not cutting into any like reusable block really?
No, so actually all collisions we need to take into account. Because even though this part is being chopped off and we have that collision there, in real life it might not fall off.
Okay, right.
But this you don't need to worry too much about the end collision yet, because we haven't told the robot the next move. So if we tell the robot the next move, the next set of surfaces, then this collision might change because we might move the robot back a bit, and etc. So maybe think about the first collision
Yep.
into the surface. Okay, so let's go back into machining, and then let's give ourselves, let's give it a little bit longer, maybe a 130. Let's try 130. Okay, go ahead and run that. You can still see that it's not quite long enough. Maybe I'm gonna give it a 150. And run. Okay, now you can see that it's above the material now at 150. You might say, actually, I think that's a bit too long. I don't want it that long. Then you can always change this, not by tangent, but by normal. And go ahead and run it. And you can see that it acts in a different way now. It actually coming across here and then cutting it, going down and cutting that little prism you see there. Okay, let's just say by tangent for now. I think it's fine. And I'm just going to have this a little bit higher, because remember, when it's engaging the robot, when it's engaging the foam, it's cutting at a cut speed, which is much slower. So you can imagine everything here, the red, it's the rapid speed. So it's actually going to approach your block at quite a quick speed before it actually gets into that engage speed, that 150 that we've assigned it. And I think this is a bit too close, for the robot to just suddenly get so close very quickly to the block. So I'm going to extend this even further to maybe 180. And then go ahead and run it. I think that's a little safer for us. Okay. And now there's a black tick saying, okay, everything seems fine, but just go ahead and check it again. What we want is a green tick, not a black tick. Does not necessarily mean it's a green tick. It just means you need to go ahead and confirm it. So here we see everything happening here, all these planes, and the way to clear this from the previous simulation is actually using this reset button. So this resets the whole piece and allows you to simulate a new action with the piece. So we go ahead and reset. This is the simulation speed. Then this is going to be the play button. So here we see the robot moving at rapid speed, going up to this point, and then slowly engaging with that 180 into the foam. Just going to speed this up a little bit. And then out of the piece like that. All right. So I don't really like this dip that the robot is giving us. So what do I do? So it doesn't collide with anything, but I would still like to change it. So if you like to change something manually on the robot, what you can do is take out this machine control panel